Motivation. We want to rapidly design new text languages by laying macros over existing compilers, then to use text-to-text translation techniques to spit out legal programs in the target language. Alan Kay said, "In a real computer science, the best languages of an era should serve as assembly code for the next generation of expression." In this short video note, I use a trivial example to show the technique of creating macros for any text programming language. Then, using only a few lines of code to expand the macros into legal executable code. Here is an illegal Go program with one line of new language code laid over it. There's the new language. That's a comment for this example. We'll turn that into a Go program. Run it. And it fails. Here's the legal version of the same program in Go. That works. This simple example is line-oriented, but the parser we use can handle structured, nested, multi-line languages. I use my language of choice to build this macro processor, i.e. a DPL based on 0D and drawio. I write source code as diagrams using drawio, using a tiny syntax consisting of rectangles, arrows, and bits of text. I could have written all of this in some text-based language like Python or Rust, etc., but I have an allergy to make work. In my mind, a DPL is a VPL. A diagrammatic programming language is a visual programming language, but with lower stress. If you want to follow along, read the README in github.com/guitarvitas/0D. I'm only going to cover steps 6, 7, and 8. The rest you'll have to read and do for yourself. FYI, one of the tools I use is RWR, which was built incestuously. RWR is a text-to-text processor which generates JavaScript code for inclusion in OhmJS project. RWR is written in OhmJS plus JavaScript. Someday, someone will rewrite RWR in RWR. This line of thinking about text-to-text translation leads back to a different technique for building languages, syntax-driven translation. But to keep things simple, I only discuss this first step of making macros with text-to-text transpilers. Once you get this part working, you can dive into syntax-driven translation. It's just more of the same, driven by a divide and conquer mindset. Tags, 0D, drawware, DPL, VPL, macros, OhmJS, rewriting, extreme functional programming using only referential transparency, rewriting, Odin programming language, JavaScript, Go, Ohm Editor, grammars and semantics, DX, developer-oriented efficiency, programming simplicity, design of text-based programming languages, actors, distributed processing. We're down to step 6. Now we're going to look at the files that were copied up. We see project.draw.io. I want to rename it to the name of this project, which is ngp2. So move project.draw.io to ngp2.draw.io. Now I'm going to modify the make file. And this project is called ngp2 make file. There we go. All the places it says project, I'm going to modify it to ngp2. Replace string project with ngp2. Done. And save. Now I'm going to modify the main.odin. And here we want to change the project name to be the project that we're doing. And we want to change the initial input from X to be a string. new datum string, and the string is going to be 4.5, and we got to make sure that string is being passed in here. That message is being passed in here. Now we'll open the drawio file. Open ngp2.drawio. This being a Mac, that command opens the drawio program on this file. And we close the general tab and we open the 0D tab. We'll start by putting an input port on the diagram, then an output port on the diagram. We'll put it over here for now. And an error port on the diagram. And I know we're going to be using this part called translate. We'll put one of those on the diagram. And then we'll, I don't know, position it somewhere here. We'll need a read text file, just that one. We'll put that on the diagram. We'll drag all this stuff over a bit just to make room for lines. And then we'll connect up the input to this thing. We'll set the line to be rounded, 2 points thick, and we'll set it as the default style for now. I like to have the input straight in there. We'll connect this output to that input. Someday I'll make them line up properly. And we'll want errors roughly here, one here, and we'll want that error to go to the error line. And we don't want to emphasize this line, so I'll put it back to 1 point and 30% opacity. Same with this error line, 1 point, 30% opacity. This is like a comment that doesn't, the colors don't matter to the compiler. And we drag this output into this output. And then we're going to need to fill in these 4 strings. So we'll start with the string thing. The first string is going to be phi, the name of the grammar, phi, and it gets connected to the grammar name, and it gets a kickoff going from whatever comes on in the input will kick off this string constant. I like to de-emphasize the kickoff line. Again, this is not something you do in normal functional programming. This is something you do with event-driven programming. This event might be kind of large, but we don't really care. They're all on the same diagram. It's really just passed by reference, and we can optimize later. Then we're going to want the grammar name, and that's going to be phi.ohm. Notice that there's single quotes around each of these to remind me what's going on in this diagram. Later, sometime in the future, I'm going to make the thing accept, check for quoted strings and generate these parts automatically. But at the moment, that doesn't happen. And then we're going to want the RWR file name, which is phi.rwr with a quote. I managed to erase it. Whoops. An overactive mouse. There we go. Bang. And one last string name, file name will be null.js because we don't need support functionality for this aspect of the project. Okay, so I'm going to drag that a little bit out of the way. Just make this diagram look a little nicer. There we go. And then we're going to put lines to kick off all the other strings. There we go. And those lines should, in my eyes, be 1 point wide and 30%. Again, because it's a comment, it doesn't really matter. I just think it looks better. My eyes are drawn only to the thick lines, and those are architecturally the more important lines. Happy path through the system is the input goes into the read text file, the file comes out, the output goes into the input of translate, and translate uses these 4 strings to open various files, and then it does a translation on the input file and outputs the result here, or if there's an error, it outputs the error here. That one isn't connecting properly to, there we go. Yes, okay, there. Like that. And then we have to save it. So on my Mac, it's a Command S. It's probably Control S or something like that on a Windows machine or Linux machine. And that's the source code for this program. In this top window, we have before.phi. It is illegal Go because of this third line here. This file represents the beginnings of our experimentation with a new language called Phi. We will layer new bits of the language over Go, then macro expand the new language bits into legal Go. In the bottom window, I've written the first cut of a macro expander grammar for Phi. We feed before.phi into the macro expander. The macro expander looks at every incoming character here and tries to match the macro that I've called Phi phrase macro here. If it fails to match the phrase, the grammar simply accepts the current character as is and moves on to the next character, repeating this sequence until no characters remain. If it does match the macro phrase, starting at the current character, it slurps all of the characters that make up the macro and moves on to looking at characters one by one that come after the macro. The grammar can do this recursively. We can have macros within macros, but to keep things simple, we don't show that here. In OhmJS, the case of the first character of the rule is significant. If a rule begins with an uppercase letter, like Phi phrase macro, then OhmJS skips over spaces. You don't have to put spaces in the grammar the way you have to with other PEG libraries. If a rule begins with a lowercase letter, like the chars rule, spaces are not skipped, and every incoming character is processed. The 3 last lines, integer, ID, and ID rest, are helper rules. At first, this looks very inefficient, but in practice on my laptop, the parser appears to run instantaneously. That's fast enough for human consumption. This is code meant for helping developers. It's not production code. Efficiency means different things. For end users, efficiency means low cost. Anything to make the code run fast on cheap hardware. For developers, though, efficiency means fast turnaround. Anything that helps automate development tasks is good, as long as it runs fast enough on development machines. The grammar we just saw is in the top window. The matching phi.rwr specification is in the bottom window. There is a one-to-one correspondence between the RWR spec and the grammar. There is exactly one RWR rule for each grammar rule. Each RWR rule must have exactly the same name as its corresponding grammar rule. RWR finishes the job that the OhmJS parser started. It takes bits of the successful parse in as parameters and spits out strings that contain characters or interpolated values from the parse. OhmJS plus RWR combined to convert text from the input language into text for the output language. For example, we input before.phi and the rewriter outputs legal Go code. The parameters to each rule are enclosed in square brackets. One parameter corresponds to one match in the grammar. For example, phi-phrase macro has 3 parameters: _def, id, and integer. Each parameter is tagged with the same grammar syntax, either a question mark or an asterisk, or a plus or nothing. In phi-phrase macro, each of the 3 parameters has no tag. But in the char's rewrite rule, the parameter char is suffixed by a plus sign. When the grammar has choices, each leg is given a -- tag name. In RWR, each choice is written as the name of the rule with a tag name suffix. In this simple example, there's only one choice rule in the grammar, the rule char. And we see 2 tagged char rules in the rewrite spec down here. There's char macro and char other. In developing the grammar, I use the Ohm Editor. I go to the Ohm Editor website in a browser. I wipe out any existing grammar and any existing examples. I write my first attempt at the grammar in an editor. Then I copy-paste the grammar into the grammar window. I open a new example and I paste in some test code. Done. When there's a green bar on the left side of the test code, it means that the parse succeeded. I double-check the parse tree in the right-hand window and scroll to see that everything looks okay. As we can see, most of the characters are just left alone and parsed as characters. We can click on things. And then the interesting part is the line of non-legal Go code that represents a line of phi code here that's parsed out as a macro. When I'm happy with the grammar, I copy-paste it back into my editor. Then I write the corresponding RWR spec. In this case, I saved the grammar in a file called phi.ohm and the RWR spec in a file called phi.rwr. At this moment, there is no REPL for helping with writing RWR specs. So I jump to the big bang and run make. And here I've got a bunch of errors. The errors start at line 13 of the Odin file. Back and look at it, and there it is. I forgot to supply a closing quote. I'll put the quote in, save the file. The colorization looks better this time. After fixing that error, I run make again. So make clean, make. So first of all, note that the L system warning stuff up here is an artifact of using Odin on Mac OS X. And now I'm getting errors for stuff that I know exists. The error points out that I haven't fleshed out main.odin by telling it which new components I'm including in this project. The fix is easy. I just add the new components to the third proc called components to include in project. In this case, I need to specify the 4 string constants that are unique to this project. In other cases, you might want to add other types of components. There are examples of how to do this. The intention is that this will be automated in the future, but for now we have to type lines of Odin code to close the loop. Back to make. And there it is, the transpiled output, with legal Go code expanded out from the line of phi code that we had at this point. To discuss further, please join us at Programming Simplicity Discord or email me.